Welcome to the deep dive. Today we're going to be exploring artificial intelligence.
Oh, yeah.
It's one of those things that's just generating so much buzz.
Yeah.
But it's also surrounded by, honestly, quite a bit of hype and misunderstanding.
Right.
So to kind of get a clearer picture, we're diving into the Teenage Guide to Artificial Intelligence.
Okay.
And I figured, why don't we unpack AI's history a little bit?
Sure.
See what's going on right now and maybe even take a peek into the future.
Yeah. Sounds like a plan. Let's do it.
So our source material, right off the bat, highlights how long humans have been fascinated with artificial intelligence. I mean, think about it. You've got ancient myths about golems, the Oracle of Delphi,
All right.
even that whole thing, that chess-playing automaton, the mechanical Turk.
It's the mechanical Turk.
Makes you wonder why we're so drawn to, creating intelligence outside of ourselves.
It is fascinating, isn't it? I think these ancient myths and these creations they came up with, it kind of reveals this deep desire in us to really understand and maybe even replicate intelligence that goes beyond our own minds. Take the mechanical Turk, for instance.
Yeah.
It was a hoax, right? But it foreshadowed this pursuit we have today with thinking machines.
Yeah.
And it's kind of poetic how the name actually lives on in Amazon's platform for crowdsourcing.
Wow, it really is. Make you think about how these early attempts, even the ones that were tricks, kind of shaped where we are now. But let's move from the myth to the reality.
Okay.
Our source material introduces some of the pioneers of AI, like Jerry Letvin and Frank Rosenblatt.
Oh, yeah.
These guys were doing some really interesting stuff.
Well, Letvin's work back in the 40s, it was really groundbreaking. I mean, he was exploring the brain as like a network of logical switches,
Wow.
which was a radical idea back then. And Rosenblatt, inspired by Letvin's work, went on to create the perceptron,
Okay.
which was one of the very first artificial neural networks.
Wow.
Imagine the excitement when that thing actually started to recognize images.
I mean, that must have felt like a huge breakthrough.
Oh, yeah.
But then our source material talks about this AI winter. What was that?
Ah.
Did Rosenblatt's work just kind of fade away?
Well, not quite. You see, despite that early success, the perceptron got hit with some pretty harsh criticism.
Oh, no.
Yeah, and from some big names, people like Marvin Minsky and Seymour Papert.
Oh, wow.
And their doubts, they really kind of cast a long shadow, and it led to funding drying up, interest waning.
Oh, wow.
It was a period of stagnation, the AI winter, as they called it, and it lasted for decades.
Decades. So how did AI come back from that? Was it just that computing power finally caught up with the vision?
That's a big part of it, yeah. Rosenblatt's neural models, the ones that were kind of dismissed, they were rediscovered in the 2010s.
Okay.
By then, computing power had just exploded, and those models that were once limited, they could suddenly be trained on these massive data sets. It was the perfect storm. It reignited that AI revolution we're seeing now.
Wow. Okay, so let's talk about how AI learns. The book breaks it down into three main branches. We've got unsupervised learning, supervised learning, and reinforcement learning.
Right.
It all sounds kind of mysterious. Is it that different from how humans learn?
Well, it is different, but there are some cool parallels. So let's start with unsupervised learning.
Okay.
Okay. Think of it like an explorer mapping a new territory.
Okay.
You give the AI all this data, but no labels or instructions. It's got to find the patterns and relationships all on its own.
Wow.
Like, they use it to cluster similar customers based on buying behavior, which helps companies with marketing.
So it's like AI's finding the hidden connections in all that data.
Yeah, exactly.
What about supervised learning then? Is that more like a detective solving a mystery?
That's a good analogy.
Because they have clues, and then they use those to make predictions.
In supervised learning, we give the AI labeled data.
Oh, okay.
So instead of just exploring blindly, it's learning a specific task. Like, if you want to teach an AI to recognize handwritten numbers, you give it tons of labeled images of those digits.
Makes sense.
And the AI learns to connect those patterns with the right labels so it can identify new handwritten digits it hasn't seen before.
So it's like giving it a set of instructions and then just letting it practice.
Exactly.
But what about reinforcement learning? Is that where it learns from trial and error?
Yes.
Okay.
Think of a video game player trying to get a high score. There's no manual. They're just going to experiment to see what works.
Right.
Reinforcement learning is similar. The AI interacts with an environment, gets rewards for good stuff, penalties for bad stuff. Through that whole trial and error thing, it figures out how to maximize those rewards.
So it's learning by doing, kind of like we do.
Exactly.
But how does all this connect back to statistics?
Yeah.
Our book says AI at its core is Statistics without bounds.
Hmm.
What does that even mean?
Well, think about the stats methods developed by the pioneers like Laplace, Legendre, Gauss, Fisher, Tukey.
Okay.
They laid the groundwork for modern AI. But AI takes those basic ideas, and with today's computing power, it creates these super complex models that go way beyond what traditional statistics could do.
How has AI pushed the boundaries of those traditional methods?
Okay, so traditional stats often makes assumptions about the data,
Yeah.
like normality or linearity. AI can handle way more complex, messier data
Right.
without needing those assumptions.
Hmm.
So it's led to all these breakthroughs in fields like image recognition, natural language processing, drug discovery,
Yeah.
where the data is complicated and doesn't fit those neat old statistical models.
That's fascinating. So it's like AI is a supercharged version of statistics.
Exactly.
But has AI actually taught statisticians anything new?
Oh, definitely more than just scaling things up. AI has pushed statistics forward with new techniques and perspectives. One of the biggest is cross-validation.
Cross-validation.
What's that? It helps fight bias and makes research more reliable by testing the model on different parts of the data.
So it's like a double check to make sure your findings aren't just a fluke?
Exactly. It's crucial in fields like, say, social sciences, where bias can sneak in.
Right.
It helps ensure those findings are solid and apply to other situations.
That's a great point. It highlights how AI isn't just about building cool algorithms.
Right.
It's about improving research across all these different fields.
Absolutely. It's about using data to really understand the world around us,
Yeah.
from the human brain all the way to the cosmos.
Speaking of the human brain, a lot of people wonder, can AI be intelligent in the same way humans are? What are your thoughts?
That's like asking about the color of the number 7.
Okay.
The question itself might be off.
Hmm.
Our very human view of intelligence might be too limited.
Okay.
Intelligence might depend on context about being successful in your specific environment.
Right.
Think about an octopus.
Yeah.
It camouflages, solves puzzles, uses tools. That's intelligent.
Right.
A dolphin, maybe intelligence for them is complex communication and social cooperation.
That's a really cool way to put it. It makes you rethink what we even mean by intelligence.
Exactly.
Is it passing a human IQ test?
Right.
Or thriving in your own way?
Exactly. And that's where it gets really interesting when we compare artificial neural networks to the human brain.
Because even though they're both called neural networks, they work very differently.
Oh, yeah.
Right.
Very differently. The human brain, it's insanely complex.
Yeah.
Billions of neurons, trillions of connections.
It's crazy.
And it's super energy efficient. It runs on like the same power as a dim light bulb.
Really?
Yeah. Artificial networks are way simpler and they're inspired by the brain, but their learning and processing is different.
What are some of the key differences?
Well, one big thing is that artificial networks are usually trained on giant data sets,
Right.
relying on patterns to make decisions. The human brain, it can learn from just a few examples,
Yeah.
and it's much better at applying knowledge to new situations.
So even though AI can beat us at certain tasks, it struggles with the kind of adaptable intelligence that we just take for granted.
That's right. Imagine how a kid learns about a cat.
Yeah.
They see a few and they get it, even if they're different breeds or colors. And AI might need thousands of cat pictures to get that.
Wow.
And even then, it might not recognize a cat in a cartoon
Oh, interesting.
because it's focused on specific visual features, not the idea of cat.
So the AI is more like a pattern matching machine.
Yeah,
And the human brain forms more abstract understandings?
exactly. And that difference affects how we even develop AI.
Could you elaborate on this?
Well, one big challenge in AI research is building models that can handle new situations and learn from limited data,
Okay.
like humans do. There's a lot of great work going on, but it's still a major hurdle.
It seems like we've still got a lot to learn from the brain
Oh, yeah.
when it comes to building truly intelligent machines.
Absolutely. The human brain is still the most amazing learning system we know.
Yeah,
It's a huge source of inspiration for AI research.
that makes sense.
Yeah.
But let's talk more about the structure of artificial neural networks. Our book talks about different types like CNNs, RNNs, LSTMs.
Right.
Can you give us a quick overview of these different architectures?
Sure.
And what are they good at?
You got the simplest type, the feed-forward neural network.
Okay.
Info flows one way, from input to output, like a one-way street. But then you have more complex ones, like convolutional neural networks or CNNs. Those are great at image processing.
Okay.
Think about how our eyes work.
Right.
They take light, process it through layers of neurons.
Yeah.
CNNs work similarly, using filters to scan images and find patterns.
So CNNs are kind of like the eyes of AI.
That's a good way to put it. Then you have recurrent neural networks, RNNs.
Okay.
Those are built for sequential data, like text or speech.
Right.
Unlike those feed-forward networks, RNNs have a memory of past inputs.
Oh, interesting.
So they understand context, making predictions based on what came before.
Okay.
Like, if you want to predict the next word in a sentence, an RNN can use the previous words to get it right.
So RNNs are like the short-term memory of AI.
Exactly.
Holding on to the past to make sense of the present.
And then within RNNs, you've got long short-term memory networks, or LSTMs, even better at handling those long dependencies in data. They're used in things like language translation or writing text that sounds more human,
Right.
because they can remember info from way back.
It's amazing how these different networks are built for specific tasks.
It is.
It's like AI is evolving specialized tools, just like we have in the real world.
That's a great way to think about it.
And that's been key to the recent progress, right?
Oh, yeah.
They let us tackle problems that were impossible before.
Exactly.
This is all so fascinating, but I'm curious, what are some of the challenges that researchers are working on right now?
Oh.
The book mentions something called the small data problem. What's that? And why is it such a hurdle?
So the small data problem, it's all about training AI models when you don't have tons of data. Those traditional AI models we've been talking about, they're hungry for data.
Yeah.
They need to be fed thousands, millions of examples.
So what happens when you're working in a field where you just don't have those huge data sets?
That's when things get interesting. There's this movement now toward data-centric AI.
Data-centric AI, okay.
It's about making the most of the data you've got instead of just wanting more and more.
So are we moving beyond that bigger is better idea with data?
I think so.
Okay.
Data-centric AI is about things like really careful data cleaning, data augmentation, which is making variations of what you have,
right,
and letting users engineer their own data specifically for training the AI.
It's like quality over quantity, right?
Exactly.
But are there other ways to handle the small data problem?
Oh, yeah. One cool technique is mixture of experts, or MOE.
MOE. Okay. How does that work?
Imagine you've got a tough task like translating languages.
Okay.
Instead of training one massive AI to do the whole thing,
Yeah.
you split it up into smaller tasks, like figuring out parts of speech, grammar, finding the right words in the other language.
So you break it down into smaller pieces.
Exactly. With MOE, you train little expert models on each of those parts.
Okay.
And then you have another model that decides which expert to use.
Okay.
It's like a team of specialists with a manager who knows who's best for each job.
That's a really smart approach. So instead of one giant model with not enough data,
right,
you have smaller, more focused ones.
Exactly. This lets you use AI even when you don't have tons of data. Each expert just learns one part, so it's more efficient, especially with less data.
It's divide and conquer, but for AI.
You got it.
It's really cool how researchers are getting creative to deal with this small data challenge.
Exactly. This is just one of many exciting things happening in AI.
Yes.
As we push the limits, we're finding new ways to make AI better, faster, more accessible.
It's amazing how it's constantly changing. I want to go back to something you mentioned earlier, those attention mechanisms in AI.
Oh, yeah, those are cool.
Can you explain those and why they've been so revolutionary?
Sure. They've really changed the game, especially for natural language processing.
Yeah.
They let AI models focus on the important stuff, just like our brains do.
Okay.
Think about reading. You don't focus on every single word.
Right.
You pick out the key words and phrases.
Right.
Attention mechanisms help AI do that.
So they help it filter out the noise and focus on what matters.
Precisely. And one of the most powerful AI structures using attention is the transformer.
Transformers. I've heard that before, but can you remind me what they are?
Okay. Transformers are a neural network type that use this thing called self-attention.
Okay.
They process info in parallel, not like those old RNNs that went step by step.
Right.
This parallel processing makes transformers super fast,
Okay.
especially with lots of data.
So it's like they see the whole picture at once
Yeah, that's a good way to put it.
instead of having to piece it together.
Right.
And this has made them super powerful for things like language translation and even generating realistic dialogue.
It's exactly.
I mean, lots of the large language models we hear about, like ChatGPT,
Right.
they're based on transformers.
Exactly.
Wow. So transformers, they've been a big breakthrough for AI, especially in how it understands language.
Yeah, they have.
Are they being used in other areas?
Oh, yeah, they're becoming super popular for image recognition and computer vision, too.
Wow.
That ability to process in parallel and focus on the important features makes them really versatile.
It's incredible how AI research is constantly pushing the boundaries.
Mm-hmm.
But as AI becomes more powerful, it seems like we really need to think about the ethics of it all.
You're absolutely right. The ethics are just as important as all the technical stuff.
Yeah.
We've got to make sure AI helps humanity and reflects our values.
It's not just about building smarter machines.
Right.
It's about the impact they'll have on society, how we can use them for good.
Exactly. As AI becomes part of our lives,
Yeah.
it's super important to have open and honest conversations about its potential and the risks. We need to work together to make sure it's a positive force.
I agree.
Yeah.
That's a really great point.
Yeah. You know, when we talk about superintelligence, we often picture something totally artificial.
Yeah.
But our source material, it also brings up this possibility of biological superintelligence.
That's right. It mentions things like genetic engineering and brain-computer interfaces as ways to, like, boost human intelligence.
Yeah.
It's kind of like science fiction becoming reality.
Exactly. And while there are, of course, ethical and practical challenges to think about,
Right.
that potential for human enhancement, it adds a whole other layer to this whole superintelligence discussion.
It really does. It makes you wonder, what does the future hold?
Yeah.
I mean, are we talking humans versus machines?
Right.
Or could it be more like a merging of the two, some kind of hybrid intelligence?
That's a possibility. Definitely worth thinking about.
Yeah.
Some futurists, they see a future where the lines blur between human and AI, where we're augmenting our brains with chips. Or even like uploading our consciousness into digital spaces.
It's kind of mind-blowing.
It is.
And it raises some big questions about what it means to be human.
Huge questions.
It's both exciting and a little scary at the same time.
Yeah.
Our source material mentions this really interesting idea that kind of connects to this Brian Hare's theory of human self-domestication.
Oh, right.
Have you heard of that?
Yeah, Hare's theory, it suggests that over, thousands of years, humans have basically domesticated ourselves.
Right.
We've become more cooperative, less aggressive. He compares it to how we domesticate animals, where breeding leads to changes like smaller size, gentler temperament.
Right.
Hare says humans have gone through something similar, and that's why we can form these big, complex societies.
So we've basically bred ourselves for cooperation.
In a way, yeah.
It's a fascinating idea.
Yeah.
But how does this tie back into AI and superintelligence?
Well, if we're more cooperative because of self-domestication,
Yeah.
does that make us more likely to get along with a superintelligent AI?
Or could those tribal instincts, even with all that self-domestication,
Right.
still lead to conflict?
That's a great question.
It's something to think about.
It really is. It feels like we're at this crossroads, We've created these incredibly powerful tools,
Yeah,
but we're still figuring out how to use them wisely.
for sure.
And the stakes seem higher than ever.
Absolutely. The future of AI is a story that we're writing right now.
Yeah.
And it's up to us to make sure it's a good one.
I agree.
We need to be aware of the consequences
Yeah.
and guide its development with a real sense of purpose.
So let's bring it back down to earth a little bit. What are some of the more immediate impacts we might see from AI, say, in the next few years?
Okay.
Beyond the obvious things like self-driving cars and personalized medicine.
I think AI is going to revolutionize the way we work, learn, even how we create art.
Wow, can you give us some specific examples? How might that play out?
Sure. So in the workplace,
We're already seeing AI automating tasks, boosting efficiency, and helping with decision-making.
right,
This could free us up to focus on more creative, strategic stuff.
that makes sense. What about in education?
In education, AI tutors can personalize learning,
Oh, wow.
helping students learn at their own pace and in a way that suits them best.
So AI could help us be more efficient and effective in different parts of our lives.
Absolutely.
But what about creativity? Does AI have a role in things like art or music?
Oh, for sure. AI is being used to make music,
Right.
write poetry, even create incredible visual art.
Wow.
It's not about replacing human creativity, but giving us new tools and possibilities.
Just like enhancing what we can already do.
Exactly.
It sounds like AI is going to impact every part of our lives in some way.
It already is, even in ways we might not realize.
That's a good point.
And as it gets more advanced, its impact will just keep growing.
So what should people be doing to prepare for this AI-powered future? I mean, how do we make sure we don't get left behind as technology keeps changing so fast?
Staying informed is key.
Okay.
Read about AI, understand its potential and its risks, and talk to people about the future we want.
Right.
Be open to learning new skills, too. AI will bring new jobs, but it'll also change some of the ones we have now.
That's true.
Being able to adapt and learn new things throughout life will be super important.
It seems like it's not about being afraid of AI, but about understanding it.
Right.
Figuring out how to use it for good.
Exactly. AI is a tool, and like any tool, it can be used in good ways or bad ways.
Yeah.
It's our responsibility to guide its development and make sure it's used ethically.
This has been a really fascinating look into the world of AI.
It has.
We've covered a lot, but there's always more to explore.
Always more.
We'll continue our deep dive after a short break. It's amazing to think about how fast AI is moving. Makes you wonder what the world will be like in, say, 10, 20, 50 years.
Yeah, who knows, right?
Our source material mentions this mind-blowing idea, the global brain.
Oh, right. That's a fascinating one.
The idea that human civilization, or maybe just the internet itself, could become this super intelligent entity.
It's wild.
Like a collective intelligence coming from all the connections between us and technology.
Yeah, like a hive mind almost.
Exactly.
Yeah.
So not just individual superintelligence, but one that emerges from the network.
Right.
That's a pretty crazy thought. What would the goals of a global brain even be?
That's the big question, isn't it? It's tough to say for sure.
Yeah.
Would it be like benevolent, trying to solve all our problems? Or would it focus on its own survival, maybe even going against our interests?
Right.
It brings up some heavy ethical and philosophical stuff.
It really does. It makes you think about the consequences of what we're creating,
For sure.
especially as we get into this territory of superintelligence. But it also highlights how the future of AI isn't just about the technology.
Right.
It's about the choices we make.
Exactly. It's in our hands.
So what can we do as individuals to help shape a positive AI future?
Well, I think the most important thing is to stay informed, to be engaged.
Okay.
Read about AI, learn about what it can do, the good and the bad,
Yeah.
and talk to people about the kind of future we want.
Right.
Have those discussions, question what you hear, and don't be afraid to ask the tough questions.
It's easy to feel overwhelmed by all this tech stuff changing so quickly.
I know what you mean.
But you're saying we can't just sit back and let it happen.
No, definitely not. We all have a role to play.
Right.
AI is going to affect all of us.
Yeah.
So we all need a say in how it develops. Don't be afraid to speak up, share your concerns, and push for responsible AI.
This deep dive has been really eye-opening.
It has.
We've covered a lot: the history, how AI works, the potential impact, even the philosophical stuff about superintelligence.
It's a big topic.
What stands out to you as the most important takeaway for our listeners?
I think the main thing is that AI is powerful, it's changing fast, and it has the potential to really change the world.
For sure.
We need to be thoughtful, ethical, and put human well-being first.
I agree.
We got to be aware of the risks, but also embrace those opportunities for good.
That's a great point. And as we wrap up, I want to leave our listeners with one last thought.
Okay.
If AI becomes able to improve itself, how can we make sure its goals stay aligned with ours,
Right.
even as its intelligence goes beyond ours?
It's a tough one.
That's a question that will keep challenging us as we move into this uncharted territory of artificial intelligence.
Absolutely. It's something we need to keep discussing as we go further down this road.
Thanks for joining us on this deep dive into the world of AI.
Thanks for having me.
We hope you found it insightful and thought-provoking. Until next time, keep exploring, keep questioning, and keep learning.